Okay, so the above decorator that we created in the last video was pretty simple, and it actually only works with functions that did not have any parameters passed in when defining them. Now, if I were to ask you to create a divider function that enables a user to input two numbers which then divides one by the other, you may come up with something that looks like the following. You may define a function called divider, so def divider, and then in parentheses pass in two parameters, one labelled A and one labelled B. You would then do something like return A divided by B. So very simple. Now this function has two parameters, A and B, and we know it will give an error if we pass in B as 0. So let me just show you this. If we put divider and then put 10, 2, we bring back 5.0 as the result. So everything working as expected here. If I now put divider and then put 20, 0, you can see that we run into a 0 division error. And it states division by 0, and when we look at what we've put in, we are indeed trying to divide by 0. Now let's assume that this function was written by someone else. We like what it does, but we just want to add our own flavour to it so that we capture the 0 division error automatically. Well, we can now create a decorator to address it. Now let's make a decorator to check for this case that causes the 0 division error. So we'll create a function called divider underscore v2 for version 2, and in brackets we'll pass in func. We can then create a nested function, so we'll once again call this inner, so def inner, and then we're going to pass in those two parameters a, b, and then we'll put a colon. We can then print out I am trying to divide and then put a comma. We can then reference the argument passed into parameter a. We can then put a comma. We can then add the string and, put a comma, and then reference parameter b. We will then do a quick check to see if the user has passed in the argument 0 into parameter b. So we can write a conditional which states if b is equal to 0, then we'll print something like stop right there. You can't divide by 0. And then we will simply put the return keyword. Now if we put nothing after the return keyword, this will just return a none object. This inner function will then return a call on the function that's passed in to the divider underscore v2 function. So we can put func, and we know that this function takes in two parameters, one labelled A and one labelled B. What's the final thing we need to do to create a closure? Well, we need to return the nested function. In this case, we need to return inner. Now you may have noticed that the parameters that we've included in the nested inner function are the same as the parameters of the function that it's decorating. But let's now call our decorator to see it in action. How do we call a decorator? Well, we can put the @ symbol and then the name of the decorator. So we can put @divider underscore v2. We can then place the definition of the function that we are decorating. So we can put def divider, and in brackets we can put a, b, and then we will simply print a divided by b. If I now call the divider function, I can put divider, and inside parentheses we can put 10, 2. When I run this code cell, we print to the screen, I am trying to divide 10 and 2, and then we bring back 5.0. So in this example, we've decorated the original function by providing this short sentence saying, I am trying to divide A and B. And if we call the divider function again, but this time pass in 0 as parameter B, so if we put divider and in parentheses put 2, 0, you can see that we print to the screen, I am trying to divide 2 and 0, and then we print to the screen the sentence, stop right there, you can't divide by 0. So we've managed to take the original function definition which we wanted to decorate, we've created a decorator, And the way we've done this is by ensuring that our nested inner function inside of this decorator has the same parameters as the function that it's decorating. But what if we didn't know what functions were being passed in and how many? Well, we can actually make general decorators that work with any number of parameters. And can you think of what we can use as a parameter that will accept any number of parameters? Well, hopefully you remember, in Python, this is done by using args and quarks. So args can be a tuple of positional arguments, and quarks will be a dictionary of keyword arguments. So if we were trying to construct a general decorator that would work with any number of parameters, we could define a decorator called generic_decorator, in which we pass in func. We can then put a colon. We can then create a nested function, so we can put def inner, and inside the parentheses, because we don't know what the parameters will be of the function that we are trying to decorate, we can put star args, comma, star quargs, which is that syntax that we saw earlier in the course, and then we can provide our own flavor. So we can put something like print I decorate any function, and you can think of this as some random piece of functionality. What I will then do is return the function as being passed in, so I can put return func brackets star args, comma, star quargs, and the final thing I'm going to do to create this closure is return the nested function, so I can return inner. So if I now have that original divider function where we had def divider a, b, and then simply printed a divided by b, I can decorate this with the decorator we created earlier, but I can now decorate it with the generic_decorator that we've created above. So if I precede the function definition with @generic_decorator and then run this code cell, and then try to call upon divider and in brackets pass in 10, 2, you can see that we print to the screen, I decorate any function, and then we get 5 returned. So hopefully you're starting to see how decorators are a very powerful feature in Python, which enable us to take in a function, provide our own flavor and functionality to that function, and then return the new function accordingly. I've attached some material in the resources section for further reading if you're interested in learning more about decorators, but if you've understood everything we've covered in this section so far, you're on your way to understanding a very powerful feature in Python. In the next section, we're going to be learning about another advanced Python concept which are known as generators, so I'll see you in the next section.